Very much. Here, this side, Satya.
Yeah, hi Satyaranjan ji. Thank you.
So definitely we'll sit as we are discussing for last some 1 year. We'll sit and we'll discuss something about the healthcare sector. And Santi has already told me also. Have you done one meeting or not with him? I told him that no. So definitely within this month we'll see. Thank you. Welcome once again, Dilip sir. So we just start the session. Later we'll talk. Thank you very much.
Yeah, thank you everyone and all the people who are participating physically. And my apology, I'm unable to participate physically. And everyone who was present online, my gratitude to them. So today this talk is about the Sami language, which is a very ultra low resource language, and how we have proceeded creating the foundational model for Sami language. And later on, we proceeded to LLM compression with the OdiaGenAI team and many people from KIIT. So we have seen the advancement in language, especially the synthetic language and computer-based language modeling in the last half a decade. But there are a lot of data present for English language. Like if we go for LLM dataset corpus, around 95% of the dataset sizes belong to the English. There are low resource language like Odia, and there are many ultra low resource language. If we go by the world's language, we will have quite many thousand languages are there, and over 1,000 Indian languages are there. So we did work with the Sami language, and Sami language has very less speaker, like 18 to 20,000 speakers are there. And we tried to work on it because we live in Arctic and the area where the northern Sami is spoken. And later on we took that, can we make it in smaller in size so that it can be used for low resource community areas. Now, what was the challenges for Sami language? It had a very limited online text data. And although there are 18 to 20,000 speakers, there are 10 dialects are there. And out of this 10, 2 dialect is extinct. For those dialects, there is no living speaker exist. So I have been in UIT Norway for 7 years, and since I moved there, I've tried to get Sami people on board so that can bring them with the digitalization world. But that Sami is a ethnic tribe or ethnic position they are holding, and they are very that community is very concerned about the privacy, and they're also worried about the loss of their languages. And so they were not really welcomed to actually collaborate with anyone. So it's like this: if you want to convert any language to Sami language, they are open to it. But if you want to make Sami language to other language, they are not open to it. But within the challenges, we try to work with whatever content available. So now Sami, how many speakers? As I said, there are 20,000 speakers are there, and almost 10 and 2 are extinct. So the amount of web crawl data available in Sami is very small, and it's already counted as endangered. And this language is spoken across northern Norway, Sweden, and part of Finland. And in general knowledge terms, the Sami people have their own constitution, and they have own virtual country, and they hold their own passport. So they may be the resident of Norway or Sweden or Finland or Estonia, but they have their own passport as a Sami. So there is a concern by Sami people as well as that will the language disappear. So they are very concerned about protecting their own language, and there are a lot of emphasis and lot of investments are there by all the Scandinavian and Baltic government to protect this language. So the type of this languages are many. Most of the languages spoken there are Northern Sami, and the Lule Sami and Southern Samis are there. The bottom language like Ume Sami or Kala Sami, these languages are already extinct. Very less people, almost no people are there, and this location is very nice. You can see this is the area where I teach and I stay there. Very beautiful. It has a lots of good feature, and Santipriya had come there, and hopefully some of you may come in the future. So when this generative AI came, we thought that can we use this to preserve Sami, and that's how we collaborated with Santipriya, and he's a low resource language expert in Odia language. So we collaborate with him along with a Norwegian student as a master student, Ronnie Paul, and we proceeded for it. So as I said, the language is a very low, ultra low resource language, and amount of data is not sufficiently available. So we had a lot of challenges. So we had to create first the data set. There was no data set existed. So we needed to create a data set and then prepare the data set for LLM training or fine tuning the LLM. So in this particular work, we did a data collection and then we did a data filtration, and then we experimented with different kind of transfer learning technique like cross-lingual transfer learning, or using multiple similar type of language like Finnish and Estonia and Sami together. So Finnish and Estonian languages are similar in language construction compared to Sami, and this language differ from other European language construction. So so we took help of those languages as well, and then we moved forward. There were other work had been done in the past, like rule-based or statistical modeling, N-gram and graphical. So I had a chance to collaborate with one linguistic expert in the UIT, and she is a Russian, but has a very strong interest in Norwegian language. So we got idea that where to find the data and how to where are the data are available. So initially we did not even have knowledge that from where to get the data, where the Sami language data is available. So we got information from Professor Laura Janda, and we tried to collect it. So she given us the information that there is a Sami community has created, and this is the Department of Sami Study in the University of Tromsø, Norway. And they have created this in last 30 years, lots of dictionary. Galatenko is a corpus name. And then there are many press releases are there. There are TV channels are there. We tried to collect data from there. And now this data had issue like, the language constructs are, when we read from the PDF, the tokenizer were not available. We had to create the Sami language tokenizer because other tokenizers were making mistakes. And it was also picking up the wrong characters, and then there were a file format condition, ASCII or this and that. So we had to put quite a lot of effort, around 7-8 months of effort to collect this small amount of data and then experiment with it. So in the pre-processing test steps, we had to exclude the non-Sami text from whatever language we got it. Then we did a normalization and then serialization, then converted it into a JSON format so that we can prepare this for the LLM training. And most of the data was in a Northern Sami. So we have to also detect a text model to make it a tokenizer for Sami language, and then garbage collection and deduplication process have been followed. So this dataset name is SALT, like Sami LLM token dataset. So how much we did? So now the vocabulary size of Sami language is around 25,000, and there are many subword tokenization as per byte pair encoding. And then after creating the tokenizer, we did a Sami language based training. So in the data set, finally, whatever data we got, around a few gigabyte of data, we are able to collect it. And then after cleaning and all the processing, we finally got only 22 million tokens. And in the present wave of language modeling, 22 million token is not enough tokening. So you can just consider that there are 2 million sentences, and on an average, there are 10 tokens in each sentences. And these texts are from administrative, religious, like Bible was a great resource. If you go for language modeling, Bible is one of the great resource because Bible has been translated in almost every language in the world. Then fiction, law, news, science, and various blogs were there. So we took an approach like auto-recursive token prediction and then did a transfer learning. We did try the joint multilingual training, like training together Finnish, Norwegian, Hungarian, and Sami. And we created the next token prediction task. So that's the work has been done by the master student in 1 year, along with support from Santipriya and postdoc Himanshu and me. So what we found that there is a benefit of doing a transfer learning from ultra low resource language. So, and we tried cross-lingual learning, and then we had to move with a linguistic similarity language like Finnish and Hungarian. So if you want to train any language, if there is a model which is trained already in a similar type of language, like let's say if we want to train Odia, and if we have any model trained in the Hindi language, then it is going to be similar language, and we will get the benefit of language similarity when we want to go for it. Since our data were very high quality, and surprisingly, if you want, I have to tell that none of us who has created this Sami language data set and foundational model on Sami have any idea about any Sami words. We don't know anything about Sami. Any word, we don't know any meaning. We had to translate anyway. So we found that we got a superior performance by doing the similar language, combining similar language and training them. So we did a joint multilingual training. Like the data set size is not a large, so the tokenized size is 500 MB of data. And we took Finnish data also, and then some Norwegian language data. So Sami is a different type of language. There is a Norway speaks a Norwegian language that also has two varieties, Norsk and Nynorsk. And we did a non-consecutive data feeding, and then also did a data balancing. We did saw performance disparity when we did a different kind of training. And we saw a small improvement when we did the joint training on the Northern Sami performance. Inference speed does increase twice between a pre-trained versus we did a random initialization. And we did saw the domain-specific bias in the output. So the implementation we did like batch size 128 and then 2 layers. Model dimension was 1024 and vocabulary is now 96,000 words were there in the vocabulary. So what we see that our D3, which is showing the cross entropy loss, perplexity loss, self-belief, and so that had a better performance, which is a joint multilingual similar language training. When we did randomize and pre-train weight, then compared to that, the D3 approach was better results. So what was the output? So let's say how the Sami language looked like. So input language, you can see that it says dog chasing the balls in the park. And since I don't know how to speak Sami or even read Sami, so you can understand that if we are creating a language and where we don't even speak anything of it. So later on, we did got confirmation from our collaborator, Laura Janda, that whether the translation is okay or not. So dog chasing the balls in the park is saying that bit packet could, so probably I'm speaking wrong. So we have got result, and and we decided not to release this LLM model after we created the Sami language. The primary reason is we were not able to create a guardrails because the guardrail which is available in the internet, which is freely available by NVIDIA or any other company, they are not trained to detect the abusive or slang or other kind of problem in the Sami language. So because Sami language dataset was not there and Sami language fine-tuned model had not been done. So our trained model can generate, it doesn't have a guardrail, so it can create anything, any absurd thing it can give you outside, which can be a challenging. So we decided not to release the model for public usage, and because it is going to be more harmful and offensive. And we also are in the Arctic and Scandinavia, where the sensitivity towards AI bias and other thing is extremely high. So that can also would have created a problem by hate speech and other profanity thing if it comes up. And further, Sami community are sensitive. So if this misuse happen with the model, then it will be a bigger political issue going to happen in Norway. So in summary, we did manage to get, apart from a language barrier we had, and the manual data collection also high. So then we went further with the OdiaGenAI team, and then we thank our people who work on this. So we thought to create a compression of this model, because the most of this Arctic area where this Sami and other things are spoken, they are under low resources, internet and other things availability, because it is a quite widespread. Very less people are living in the area. It's like a desert, the ice desert area. So we had to create a smaller model. So we went for the LLM compression. So, and compressing the LLM or creating the edge device is not feasible for any small and medium enterprise. So we try to work on it to see whether compression techniques can help. Why it is needed? As we know that LLM dataset, which is available as per June 2023, with a 3 billion web page and 400 terabyte of uncompressed dataset, and 21 trillions of tokens are there in the public repository of dataset. So this is going to take a huge amount of time, and that is why we need compression and why we need a compression. So Llama 3 typically had used 6 trillion token, and they has used A100 many GPUs, and almost 80 million A100 GPU hours were there. So they had used close to 20,000 A100 GPU, and its estimated cost is 720 million only for GPU. So it's not feasible for a small enterprise or even a small country to do it. So we decided to go for a compression. Now compression has a 4 to 5 different types of compression method. First compression method people try is a quantization. We will see what is a quantization, and then pruning, where the different network connection in the LLMs are evaluated, and then the connection which are not having a strong emphasis, they are been identified and they had been removed or made null from the connection. At the knowledge distillation, what typically is done, we take a bigger model, let's say Llama, and then we take a smaller model and we transfer the knowledge in the Llama, which is a bigger model, to a smaller model, like a teacher and student model. And then there are other methods like low rank factorization, mathematically intensive, and there are many famous approaches are there, LoRa. So these are low rank factorization gives you adapter model. So that's the technique. So if we go by pruning and what is a quantization. So in pruning, we typically remove the entire weights or neuron, which has a little impact on the output. This does help in reducing the model size by removing unnecessary connections. So inferencing also becomes speeder. but it required retraining to recover the accuracy which was lost. So people generally go for quantization approach. So in quantization, in the deep learning or LLM based training, typically we use a 32-bit floating point precision. And there the precision of the weight is reduced from 32-bit to 16-bit, 8-bit, 4-bit, 2-bit, and even a 1.5-bit and 1-bit recent years. So in this case, the architectures are kept same. The memory and the speed of the inference are only done. So this quantized models are easier to deploy on edge devices or low resource hardware. Pruning, we can see that before pruning, so many network connections are there, and once the pruning is done, so only the important network connections are identified and kept, and rest all connections are being removed. While in quantization, as we see, if it is a 3x3 network is there with 32-bit quantization precision floating point. And if we go for a 2-bit quantization, then this 32-bit will be mapped to a 2-bit, that is 0001, 1011, and the value is 0123. So we can see that minus 0.6 and minus 0.7 is matched as 0 index, and in a bit it is value 00, and its value will be minus 0.6. While the index 1 or bit 01 representation has a value 0 and 10 has 0.4, and while 11 has value 1.1 and above. So quantization helps to give immediate compute and memory saving without architecture change, and it typically compatible with CPU, GPU, and neural processing unit, NPU. And this approach have been greatly used by LLM compression methodologies. So we, in our work together with OdiaGenAI team, we work on post-training quantization approach. Means after the training is done, we did a quantization after the post-training. And another approach we applied is a group scaling quantization. So post-training quantization is a very fast, no need of full training. We do a very small training. In hours, we can do instead of weeks. And it does have the accuracy loss, but it is smaller. And the storage amount cut is quite great because 32-bit to we can go to 4 to 8-bit, and storage requirement we can reduce by 4 to 8 times. While group scaling quantization, we found that it retains the activation better, and it works very good for 4-bit representation and effective with ultra low precision. The size reduction we have seen in a group scaling quantization is 13 times. So, and it is a very aggressive both in memory and inferencing speed. So we went for this approach. We call this project name FedCom. Yesterday you have seen FedCom related information given by others. So here we saw that we can see the compression up to 13-fold size, and we tried with many models, including Llama 1 billion model, and we saw it performs better than some tasks, than the original for some tasks. There are trade-off is there, that accuracy drop in slight, but we are able to do a major memory saving. Since this is a smaller model, which is 13 times smaller in size, it can run on smaller devices like mobile or IoT devices. So what we saw, the reduction, we can see that from 32 representation, we can see 8 GB representation, and also the throughput is increased, inference speed is increased from 200 millisecond to 140 millisecond for GSQ, GPTQ, and 120 millisecond for GSQ approach. And flops are also being reduced considerably. So in terms of other model like Phi 1.5 billion model, we just see that unquantized and quantized for different kind of data set like GSM 8K squared or MS Marco or BoolQ. We did saw the quite a great reduction in the memory and also the throughput. So important is that what is the perplexity score is an important metric in LLM domain. So we have seen quite good approach via the GSQ approach. Perplexity score before means pre and versus post quantization. Now comes the limitation. What are the limitations are there? So one of the limitation is that in GSQ approach is that group size is fixed. We won't be able to change the size. Second is we cannot do the varying layer sizes. It has to be in the multiple of 4, 8 like that. Then it does suffer challenges with fine-tuned model. Like if we have taken a base model as a fine-tuned model and GSQ approach, we have seen some lower accuracy. And since it is quite restrictive, it doesn't have a fallback mechanism because once we have started, we do not adapt later. In conclusion, when we did this LLM compression, and what we saw that we are able to see the better performance again for quantized Llama 1 billion model over the original Llama 1B for certain tasks, while BoolQ tasks remain mostly unaffected by quantization. And in GSM 8K, which is a mathematically heavy, has seen a precision loss. It has shown metric like latency and throughput show a very minimal negative impact when we did a 4-bit quantization. And 4-bit quantization is practical for deployment. What we saw that our learning takeaway is that there's a trade-off exists between accuracy, retention, and computational efficiency. Now we have to go further in future that how we can do a layer-wise study of 4-bit quantization and its effect on the overall performance and across various tasks. I would like to thank my co-author of this work. Sahil has done very good job. Devasis, Sonal Khosla, Akash Kumar Dhaka, and Santi Priya, SK Muhammad Sahid, Sambit Sekhar Mishra, and Andres Bozar. So to take finally, now to truly include every language in the AI age, now there are so many languages are there and all the languages need to be given emphasis. So we must make AI not only smarter but lighter so that it can serve the even the smallest voices. And just last week, this book on AI compliance and guardrailing AI models and preventing the bias on the AI models has published. So, and we are also conducting summer school first week of August in ISM on it, IIT ISM Dhanbad on it. So I would like to say thank you to all. If any question and can cover. I have been pretty fast, look like. Any question in the audience?
Hello.
Yes.
Hi, Dilip. Are you audible? Am I audible?
Yes, you are audible.
Okay. My question is, if I'm going for semantic similarity search for a RAG-based application, and I'm using quantized version and non-quantized version, so which one has a better thing? And if quantized version is used, is there any reduction of the similarity in the output?
So question is quite thoughtful, like, semantic similarity search. So as we know that when we are going for quantization, so we need to know what is your target. Means if you want to get a higher accuracy is your primary purpose. If you want to have a higher accuracy as a primary purpose, then the unquantized version is going to help you.
Okay.
But if you can manage to have a smaller drop and get a compression effect as well, then quantization approach can be useful.
Okay. And any other use cases where we can use quantized versions, like similarity search or summarization? Any examples you can give so that it will be useful for the people who are not very
So
technical?
the examples are like this. Now our phone, every company are coming up with AI. The Samsung AI, Apple AI, and many AI. So if they are running their AI model on the phone, for those cases, it is going to be helpful. That if you have, let's say you are from the Odisha area, and that area a lot of mines and other things are there, and there are voice control, LLM based voice based support system available in the mine. In those area, this can be helpful because it doesn't consume a lot of energy, and also the cost of the device can be kept same what presently people are using. So those kind of some of the examples are there.
Okay. Thank you, Dilip.
If at all our online participants also have any questions, they can either put it in the chat box or they can unmute and ask.
Is there any question from online participant, or if any from? Is there any question from online participant or offline? If not, then we can close the session. So thank you, Professor Dilip, for the talk and accepting our invitation and presenting some of our research work, and hope we can do something more in the LLM compression. Although we started in initial work, hopefully we'll do many more things. And those, some of participants have a question. Yeah.
Sir, after it is done, the Sami language LLM has been created. How are you taking it forward? How is it being implemented or being used by the community?
So unfortunately, the community is not using it. We need to first guardrail it, and acceptance from the Department of Sami Studies is not there. And also, we are not able to get any Sami language, another student who has expertise in Sami language, because to create a guardrail, we will really need a linguistic expert. Otherwise, we won't be able to get. So currently it is lying in our server, hoping that we can get some student interested to work further on it. But I'm sure there are other people in the other university, they are working on it. And some of them have asked the dataset from me, and I have given them the dataset.
So the follow-up question will be, which is more valuable, the model or the data?
Data.
Thanks, sir.
Data is the most valuable thing.
Yeah. So I get that, sir. The repo you have created by collecting the data will be helpful in creating much more enhanced models.
Yes.
Thank you, sir.
Yeah.
So is it possible? Is it publicly accessible, or is it just?
No, we have not given the publicly accessible. If you request, then I can share.
Sure. I'll get in touch with Professor and I'll get to.
Yes,
Yeah.
sure. Yeah, you can.
I have a follow-up question. What motivated you to get into this
Yeah, so
Is there any financial kind of like involvement, or is it government sponsor, or it is how do you do that?
yeah, maybe please provide the mic. So there is another question for you, Dilip. Yeah, please. Yeah.
Again, I can repeat my question. Hello. See, what motivated you guys to build this particular model? That is one. And what kind of support you got from the government or colleges or any financial kind of like firms? Something. It's pretty kind of like curious to know. With a very limited Sami people around, why you guys got into this one?
So if you want to, so our interest is that that we are the computer science people, so we should do something for, we work in the Norway, and Norway has two major languages. One is a Norwegian, other one is a Sami. And we saw that there is nothing on Sami that motivates us to work on Sami language. Now, what support, we haven't got any support from any government or any Sami community or any department of Sami studies or a Sami minister or anyone. But after we published this work, it has got attention in many podcasts and newspaper recently. Last month only, the Minister of Sami Study has appreciated our department that we are working for Sami people.
Good. Thank you.
Actually, for the Sami language, this Odia language model, what I presented today, in Finland there is something called Finnish AI Day, like where researchers can come and showcase their research work. And there I presented this, how we build this fine-tuned model for Odia. And there Professor Dilip made, although there many people asked me, they are also curious to know how you guys have made an LLM where there is no data or a low resource. And there Professor Dilip met me and asked, okay, how did you do for Odia? Can we do for some another language, Sami language? I said, yeah, surely we can help. Then there the collaboration started, and I visited last year also to UIT for lecture series on generative AI. He conducted a lot of lecture series, and from there we started guiding the master student, and the collaboration still going on. Recently, this LLM compression, we are started a collaboration and even submit the first paper, and we are doing. So anybody is interested, feel free to contact me or Professor Dilip. Yeah.
Actually, Santipriya, may I add? So after meeting you, I actually changed the direction of master student to creating foundational model for Sami language. It was not in the beginning.
Yeah.
So before that, it was a model compression student was doing, but after meeting you, I created a foundational language for Sami for him, and he agreed for it.
Yeah.
Good.
So I think if there is no more question from online or offline, then I'd like to thanks Professor Dilip, and it's always nice to talk to you. And even last year also he came to our conference, although it is in virtual mode. And also this time we planned for a physical, but due to some other work he could not join. But hope next year you will be there here.
Yeah, actually, KIIT, I really wanted to visit, but somehow, for some personal reason, I am unable to visit actually. Yeah.
Okay, thank you.